All right, friends, welcome back. So this is going to be part 2 of day 1 of section 1.6 of your textbook. In the last video, we talked about how to solve polynomial equations, and in this video, I'd like to go ahead and review how you would solve your rational equations. Okay, so remember that a rational expression is going to be an expression where it looks like a polynomial over a polynomial as a fraction, right? So if our equations involve those, we just need to review a little bit about how we would solve them. So the steps for that are right here. So it says step 1, you would want to multiply the entire equation by the least common denominator to get rid of all the fractions. So that's that process that we've discussed in previous videos and lessons of clearing the fraction. We want to get rid of all those divided bys before we continue, okay? And then it just simply says to solve. And then because we have these rational expressions, remember that one of the things we definitely need to make sure that we do is check for those extraneous solutions. Those would be, again, solutions that we would get by the natural problem-solving process, but when we try to plug them back in, it creates problem for us like a 0 being in a denominator, which of course is never something that we want. So let's go ahead and review that process here really quickly in a couple of examples. So number 1, we have this equation right here, some rational expressions, some fractions, right? And we can see here that we definitely have some divided bys. We have specifically a divided by 3, and we have a divided by 4. So in order to clear the fraction, we need to think about this as multiplying the entire equation times something that's going to encompass both that divided by 3 and that divided by 4. So here's where we would go ahead and multiply the entire equation by the least common denominator, which of course would be 12 here, okay? That 12 is going to get divided by 3. And when you do 12 divided by 3, you're going to get 4, and then we would multiply that 4 times that remaining copy of x in the numerator. So we would simply say 4x there, okay? When we distribute that 12 to the second term, we're going to say 12 divided by 4 is going to give us 3, and we're going to take that 3 and multiply it times that 3x that is remaining in the numerator. And so 3 times 3x, of course, is going to give us 9x, and then we have an equal sign that drops, and then we would do that last distribution. So 2 times 12, that's simply going to give us 24. Okay, and so again, by multiplying by 12, it clears all of those fractions, and it gives us the ability to solve this really easily, because on the left-hand side, you just have a couple of like terms that you need to combine. So 4 plus 9, that's of course going to give you 13. X is equal to 24. And then after that, you would simply just go ahead and divide both sides by 13. And we would get here x is equal to the fraction 24 over 13. Remember to be writing that as an improper fraction. I have a couple of students here that like to use mixed numbers, but those are never the way we want to go ahead and leave our final answer for problems like these. And of course, just checking here really quickly, we did not have x showing up in the denominator of any of our fractions, and so this would be one where we don't necessarily have to go through and check that solution, although you could in the calculator very easily. And number 2, this is a special case of a rational expression where you have a single fraction equals a single fraction. And so if you ever have this situation, a single fraction equals a single fraction, just remember that this is one of those situations that you have the green light to go ahead and perform a cross multiplication, okay? And so we're going to go ahead and multiply the top of one times the bottom of the other, and so we know how to write that. That would be 3 times the expression 5x minus 4. We're going to go ahead and set that equal to the other cross of our crisscross here. So that would be the expression 5x plus 4 times a value of 2. And so we know how to write that too, right? That would be 2 times the expression 5x minus 4. In which case, we would now just go ahead and perform some distributive properties. So distribute 3 into the expression on the left, distribute 2 into the expression on the right. So that would be 15x minus 12 is equal to 10x minus 8. And then just go through and combine your like terms, right? So you're going to go ahead and combine your variable terms next here. So that would be 5x minus 12 is equal to negative 8. And then, of course, you would just add 12 to both sides here, in which case we would see here that 5x is going to be equal to positive 4, it looks like. And then last step, we just need to get rid of that 5 in front by dividing both sides by 5. And we definitely end up with an answer here of x is equal to 4/5. Okay? And so just checking here really quickly to make sure that that is not an extraneous solution, we should be plugging that back into our equation and seeing if it creates an equals 0 on the denominator, okay? Well, the only time that x shows up in the bottom in our original equation is right here. So if we were to go ahead and plug in a 4 over 5, then we would just have to check to make sure that we get a 0 in the denominator or not. If we do, we have to throw our solution out. But here I think we're good, because I believe if you were to plug in a 4 over 5, then that orange denominator there, that would turn into an 8, and that is not 0. So we know that we have the right answer there. And of course, we have talked about in previous videos how to store these values into x in the calculator. Type in the left-hand side, see that it equals the right-hand side. In an example like number 3, we have a bunch of different denominators here. One of the things that we always need to make sure that we remember is that we always need to make sure that we factor the denominators as much as possible. So this denominator that I'm highlighting right here, this can definitely be something that factors in the following way. You could factor out a GCF and call that x times x minus 3, okay? And the reason that that's important is, again, because we're going to clear the fraction here, and what we need to do is multiply times the LCD of the denominators. So basically what you're going to be doing, folks, is you're going to be multiplying the entire equation times everything that shows up in a denominator. So, for example, I have a divided by x that shows up in a denominator, so I'm going to make sure to multiply by x. What else do I have? Well, I have a divided by x minus 3 in the denominator, and so that is why I'm going to go ahead and multiply times a copy of x minus 3. And again, it's important that you factor that other denominator there to realize that you basically have both of those terms here. You have the x and you have the x minus 3 in that factorization. So that's pretty good. So when we go ahead and distribute that in now, we're going to see that a lot of this stuff cancels. Okay, so for example here, we have the x times x minus 3 canceling out with this x times x minus 3. So that means that that's going to cancel. And we would just simply be left with 3 as the only term remaining in that first term there. And then when we go ahead and distribute this to the second term there, remember that this divided by x is going to cancel out with this times x, and you're just going to write what's left over there. So left over there is just simply going to be a 4 times the expression x minus 3. Equal sign there. And then what we're now going to go ahead and do is distribute that to the very last term. Of course, this divided by x minus 3 is going to cancel out with this times x minus 3 and just leave you with what's remaining. So that's just simply going to be 1 times x, or in other words, just 1x there, or just x. Okay? And so again, by multiplying by that x times x minus 3, that clears the fraction, and now it's taken the whole problem and turned it into just this, which is very, very easy to solve. We're just going to go and follow up with some distributive property there. So 3 plus 4x minus 12 is equal to x. Combine some like terms there. You got a 3 minus 12 that's going to make negative 9 plus 4x is equal to x. And then, of course, just subtract 4x from both sides of your equation. And we would end up here with negative 9 is equal to negative 3x, and then divide both sides by negative 3. And you would see here that x is equal to negative 9 divided by negative 3, and that is positive 3. Okay? Now, before we box that as our answer, again, we always need to make sure that we are checking to see if that creates any problems for us in the original equation. And I think here you'll notice that it does, because if I were to plug in 3 into this denominator specifically, then I would have 3 minus 3, and that would make 0 in a denominator. So again, this is what we would call an extraneous solution. Okay? So extraneous solution. We introduced that topic in a previous video here. But because we did end up with an extraneous solution, we need a new conclusion rather than our conclusion just being x equals 3. We had to throw out x equals 3. So we would conclude here that we have no real solution to this equation, making this equation one of those conditional equations that don't have a solution. Okay? And then finally, in this very last example here, it would be the exact same concept. We just have a bunch of rational expressions here, and we just need to go through and multiply everything times a copy of whatever shows up in a denominator. So I see here that we have a couple of different divided bys here. I have a divided by x minus 1, I have a divided by 3x plus 1, and then I have another divided by 3x plus 1. So I'm going to go ahead and multiply times copies of whatever shows up in the denominator for us. And that's going to be these right here. And again, just kind of going through, making sure that things cancel and writing out what remains. So we're going to have 3 times the expression 3x plus 1 plus 6 times the expression x minus 1 is equal to 15 times the expression x minus 1. Distributive property where it applies, so 12x plus 4 plus 6x minus 6 is equal to 15x minus 15. Combine some like terms there on the left-hand side. So you're going to have, let's see, that would be 18x minus 2 is equal to 15x minus 15. Maybe combine your variable terms at this point, so subtract 15x from both sides. You would simply be getting 3x minus 2 is equal to negative 15, and then that's just a simple two-stepper from there on in. So you would add your 2, and that would give you, of course, 3x is equal to negative 13. And then, of course, after that, simply dividing both sides by 3, x is going to be equal to the fraction negative 13 over 3. Okay, and that represents your solution. Now, again, we should check to make sure to see if that creates a problem for us by plugging that back into all of the different denominators that we had in the problem. Okay, I think you'll find that if you were to plug in negative 13 over 3 here, you're just going to take that minus 1. That's not going to end up being 0. And then if you were to plug it in here and here, that would just be 3 times negative 13 over 3. That would just be negative 13. And then when you add your 1, that would result in a negative 12 in the denominator. And that, of course, is not equal to 0 either. So we know that we are good to keep this, this one solution that we had. Okay, and so that's going to do it for this video. Again, the basic problem-solving process is you're going to clear all of those denominators, clear all those fractions by multiplying the entire equation times copies of whatever shows up in the denominator for you. Okay, and so that's going to do it for this video talking about rational equations. As always, if you guys have any questions, let me know. Thank you very much for your attention, and I will speak to you guys in this next one.